Okay, today we're going to talk about some different chemical models that we're going to be seeing or that you have seen as we work through this unit. And some of the chemical models have different structural elements to them. The Bohr model, for example, all right, is a series of concentric circles with the nucleus of the atom in the middle and the surrounding electron shells or orbitals. Okay, one of the ways I remember the Bohr model is this structure is because the O in Bohr kind of looks like these concentric circles. Another model that you'll see or representation of the atoms that we're dealing with are called Lewis dot structures, and they deal with valence electrons, and that means the electrons in the outermost shell. And what you'll usually see them is written as is there a chemical symbol such as like carbon and dots around it representing the valence electrons, the electrons in the outermost shell of those atoms. And the third thing we'll be seeing is electron configuration. And the way I remember this one is because of the term figure. And the electron configuration represents the number of electrons in each orbital or shell. And if you remember, we talked about the K shell, which is the innermost electron shell closest to the nucleus, the L shell, and the M shell. Okay, we might hit the N shell a little bit, but not too much. And what you'll see is numbers representing the number of electrons in those shells. And if you remember, we have 2 electrons in the innermost shell. The K shell can only hold 2. The L shell can hold 8. The M shell can hold 8. And the N shell can hold, they are subshells, but the outermost shell of the N shell will hold 8 as well. But we're not even going to get into that at this point. Okay, so we'll just leave that blank for now. So what we're really talking about are models that give us a visual representation of the atomic structure. All right, the Bohr model is your most basic, and you see that you've probably seen this. You've seen me draw positive protons and neutral neutrons in the nucleus of cells. Okay, for instance, if I drew this, you'd be able to tell me that you have the protons here, and by counting the protons, you'd be able to tell me that this is a nucleus of a lithium atom because there's 3 protons there. And you know the atomic number is therefore 3. And you could tell me the atomic mass of this atom by counting up the protons and the neutrons, which would be 7. So this is a nucleus of a lithium-7 atom. Okay. You also might see it written when you get a lot more, or more, I should say, protons and neutrons in the nucleus. It's really time consuming to draw all the pluses and the circles and whatnot. So you might see them write it as like in a sodium atom you'd have 11 protons, okay, and 12 neutrons in the nucleus surrounded by the electrons in the outer shells. But you wouldn't even get to the M shell here. You would just get the K and the L shell because you only have, actually, you would get to the third shell, the M shell, excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, and you would have the 11th electron in the outermost shell, the M shell. Okay. Okay, so that's your general Bohr structure. All right. If I were to ask you to give me the the Lewis dot structure for either one of these, they would look very similar because you'd have the symbol and the outermost electron dot. Lithium has 1 electron in the outermost shell. So it has 1, 2, 3 electrons. So this represents the valence electrons. If I ask you to draw me the Lewis dot diagram for this sodium atom, remember this is an atom of sodium, you could write it like this as well. Okay? So you have the symbol for sodium and the 1 dot representing the valence electron, the outermost shell electron. Okay. I'm just going to draw the first 4 Bohr models for the 4 elements here at the top: hydrogen, lithium, sodium, and potassium. Now, hydrogen's actually not a metal, but because of its atomic structure, it's put in the same family or group. Okay, group 1. It's put in the same family as lithium, sodium, potassium, all the way down to francium. group 1, and those are called the alkali metals. Okay, so to draw the Bohr diagram for hydrogen atom, it has 1 proton in the nucleus and 1 electron. Bohr diagram for lithium. It has 3 protons in the nucleus, 4 neutrons, okay, and 3 electrons. Notice that the outer shell only has 1 electron in both of these atoms. And the Bohr diagram for sodium is going to look like it did on the last page, but it's going to be a little more messy because it's my handwriting. Okay. 2 electrons in the innermost shell, the K shell. Once that's full, you start filling up the outer shells. All right, so you can fit 8 electrons on the L shell. And once that's full, the last electron ends up, on the M shell. A little left turn there. Okay, once again, you'll notice the outermost shell has 1 electron. And in potassium, okay, I'm going to draw this over here. You have 19 protons. 20 neutrons. Okay, and remember, a way to calculate that is if you know its atomic number is 19, you know it's 19 protons. Its atomic mass is 39. So 39 minus 19 equals 20, and that gives us our number of neutrons. Okay, once again, in the innermost shell, you have 1, 2. The L shell, you have 8 electrons. M shell, you have another 8 electrons, which brings us to 18 electrons. And in the N shell, you have that 1 extra electron there. So you notice they all have very similar physical structures. All right? And that leads to them acting very similarly with regard to their chemical reactions. These atoms like to give up their outermost electron, not including hydrogen. The other metals, okay, lithium, sodium, potassium, like to give up that outer level electron. So they act very similarly. They're structurally similar, and therefore they react chemically similar, because most atoms that want 1 electron will take it from any one of these. So they react with many of the same chemicals that the other ones react with. Okay? Now, if we're going to write a Lewis dot structure for each one of these, we would just write the symbol and the 1 electron dot for the corresponding valence electron. Okay, remember, these valence electrons just means outer shell, outermost shell electrons, okay? Now remember, each shell has a corresponding letter, K, L, M, N, etc. As you saw before, K, L, M, N. Okay? So if we're going to draw the Lewis dot structure for this lithium atom, it would be Li and a dot for the corresponding electron. For sodium, once again, corresponding electron, and potassium. Okay, and that's representing the valence shell electrons. Now, if we wanted to do an electron configuration for one of these, we're just going to write the number of electrons in each shell with a little dash in between them. So hydrogen only has 1 shell, so its electron configuration looks like this. The electron configuration for lithium, you have 2 electrons on the K shell, right? And on the L shell, you have 1. For sodium, okay, so for sodium, you have K, L, and M shells. You have 2 electrons in the innermost shell, 8 in the L shell, and 1 in the M shell. And for potassium, you'll see we have K, L, M, and even we have an electron on the end shell, but same thing. You have 2 on the inner shell, 8, 8, 1. And you'll notice that they're all similar in the fact that in their outermost shell they have 1 electron. And once again, we said that allows them to act very similar chemically. Right? It also is the reason they're in the same family. They are very similar to each other. All right? So elements in the same family are very similar and will react similarly and generally have very similar physical traits as well. Okay, so here we have the first 18 boxes on the periodic table. Okay, normally there's the big section of transition metals in there, but we're going to just concentrate right for now on group 1, group 2, group 13, group 14, group 15, group 16, 17, and group 18. Now group 1 and 2 have special names. One is called the alkali metals. Group 2 are called the alkaline earth metals. 13, 14, 15, and 16 just have the name of the first element at the top of each column. So 13 is known as the boron group. Okay. Then you have the carbon group. Okay, in group 14. Then you have the nitrogen group. And the oxygen group. And then group 17 has a special name for its elements. They're called the halogens, just like the lamps. And then the group 18 are called the noble gases. They don't really react with anybody. The most reactive metals are in group 1. The most reactive nonmetals are in group 2. So group 17 and 1 really like to react with one another quite often. But let's get to the Bohr models for all these guys. So if you remember, we'll start with lithium. We already did hydrogen. It's pretty simple. If we have lithium, okay, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and we had up here helium. But we're going to start with neon. The Bohr structure for helium is pretty simple, okay? It has 2 protons, 2 neutrons, all right, surrounded by an electron shell with 2 electrons in it. Very stable. Doesn't want to fill that shell out. It's already the shell is already full, so it can't even add any more, and it doesn't want to lose any. All right, we already did the lithium. Okay, Bohr diagram and Lewis structure. So we'll start with beryllium. Okay, and beryllium has a Lewis dot structure of 2 electrons in its outermost shell. Okay, it has 4 protons, 5 neutrons in the nucleus. So it has 2 electrons in the K shell and 2 electrons in the L shell, and that corresponds to the Lewis dot structure right there. And its electron configuration would then be 2 for the K, 2 for the L shell. Okay, I'm just going to do magnesium real quick below you so you can see the corresponding similarities in Lewis dot structure where you have 2 electrons in its outermost shell. Okay, magnesium has 12 protons in the nucleus and 12 neutrons. Okay, and that nucleus is surrounded by a K shell, an L shell, and an M shell. Okay, and on the K shell it has 2 electrons, 1, 2, and then it has 8 electrons in the L shell, which gives it a total of 10 electrons so far that we're drawing. Okay, and it has 2 electrons in its outermost shell. So remember, the atomic number for magnesium is 12. Okay, so it has 12 electrons, and it has 2 electrons in the K shell, 8 in the L shell, and 2 in the M shell. Okay, now to show you the boron group. All right, starting with boron, you have 5 protons, 6 neutrons in the nucleus. So boron has an atomic number of 5. It has 3 electrons in its outermost shell. It's in group 13. All the elements in group 13 have 3 electrons in its outermost shell. All the elements in group 2 have 2 electrons in its outermost shell. In group 14, the carbon atom, you have 4 electrons in the outermost shell. We'll get to that in a second. The carbon group, excuse me. Okay, you have 1, 2 shells, 1, 2 electrons in the inner shell, 3 electrons in the outermost shell. Its electron configuration is 2-3. Okay? When you talk about the carbon group, all the elements in the carbon group have 4 valence electrons. Carbon has an atomic number of 6, so it has 6 protons, okay, and 6 neutrons, because atomic mass is 12. Okay, so it's 1, 2. So it's 2 electrons on the K shell. 1, 2, 3, 4 electrons on the L shell. Okay. If we went down to 4, I'm going to just show you the last 2 in this period here. Fluorine has an atomic number of 19. Atomic number of 9, atomic mass of 19. So you have 9 protons, 10 neutrons in the nucleus. You have 1, 2. You have 1, 2 electrons in the K shell. 1, 2, 3, 4, 5, 6, 7 electrons in the L shell. So its electron configuration is 2-7. Neon is a noble gas, which means it doesn't really react with anything. Its structure, it has 10 protons. Its atomic number is 10. It has 10 neutrons in the nucleus. It has 2 shells because it's in the second period. Okay. 1, 2, and then it has a full outer shell with 8 electrons in the outermost shell. Okay. What you should start noticing is that all the elements in the second row of the periodic table, the second period, all have 2 energy levels or 2 orbitals. In the third row, they all have 3. Okay, and I'm just going to draw a quick aluminum one. It's in group 3. What you'll start to notice is it has a very similar structure, especially in its outer orbital, to the boron atom. Okay, and aluminum has 13 protons, 14 neutrons, okay, aluminum. Its Lewis dot structure is going to look like this. See, 1, 2, 3, 4, 6, 7, 8. 1, 2, 3. So now its electron configuration is going to be 2, 8, 3. So now if you go across, basically you'll see that these numbers are increasing. Nitrogen is going to be 2, 5, 2, 6 will be oxygen. Okay. Here you'll have, next to aluminum, you have silicon, which is 2, 8, 4. All right. Then you have phosphorus and sulfur. 2, 8, 5, 2, 8, 6. Okay. But what you'll start to notice is the outer shell electrons in each family are the same, and that's why they're in the same family. I hope this explains a little bit about the atomic notation that we use or have been using in the last couple of days, and in the future you should become very familiar with this, because you will have to look at diagrams like this and be able to tell us different questions or answers to different questions. Okay, but just let's look at this. If you want to remember the Lewis dot structures here, I'll draw them on the top. For the group 2, you have 1, 2. For group 3, you have 1, 2, 3 dots around it. For group 4, 14, 13, I should say, and 14, you have 4 dots around it. For 15, 1, 2, 3, 4, 5. For 16, 1, 2, 3, 4, 5, 6. For 17, 1, 2, 3, 4, 5, 6, 7. And for the noble gases, 18, with the exception being helium, you have a full outer shell in all of them. Okay? See you tomorrow in class. Have a good day.